This is a video on a new product called NeuroLink and NeuroLink Pro. On the right-hand side of this screen here is an overview of what NeuroLink Pro is and how it integrates with NeuroGuide. The goal of NeuroLink Pro and NeuroLink in general is to link patient symptoms to patients' brains. It starts with the patient doing an assessment, and also the clinician, of course, can do their own neuropsychological or clinical evaluations. But in addition to this, the patient can do self-assessments of a number of different categories of symptomology. They can do that on a smartphone, like you see this lady holding, which gives rise to a severity index of different categories from attention, anxiety, depression, memory problems, etc. The severity of the symptoms is in this bar over here, and the goal is to have the length of these bars be reduced towards zero. And the smartphone or the NeuroLink Pro that's on a variety of different platforms, Macintosh, PCs, tablets, as well as a smartphone, can be then imported into NeuroGuide. And the particular symptom area linked to networks in the brain can be selected, and then neurofeedback can immediately begin, or one can assess other treatment methods. Could be rTMS or TDCS or medications, ketamine, etc. And then once one then evaluates the severity of the symptoms over trials or over treatments or over time, and then this creates a loop where the individual continues to interact with the clinician remotely or in the clinician's office with treatment that then moves the patient's brain towards greater stability and efficiency. Now, the patient can find a clinician if clinicians subscribe to this map in the lower right. And by clicking on a map or one of these dots near where the patient is located, then the clinician information will come up, contact information, email address, telephone, whatever information the clinician wants on this that comes up for the map. It's tailored fairly extensively. I'll be showing that in a minute. The left-hand side here shows the NeuroGuide with the main title here, and purpose of this discussion is linking symptoms to brain networks. And when you bring up NeuroLink Pro, can activate these various documents, including the Handbook of Quantitative EEG, and NeuroLink and NeuroGuide, etc., and also send an email to Applied Neuroscience. But for now, I'm going to bring up the NeuroGuide, and we're going to start there, and then we'll come back to NeuroLink, because NeuroGuide, most people are familiar with. Historically, it was developed first. One scans all the data, one then makes sure that there's no artifact in the selections. One verifies that it's got at least 0.9 retest reliability. One can then save this, edit, and then clear all selections and make a different selection, and keep doing that until you're satisfied. And you can do this 3 selections like in a courtroom in less than 1 minute or 2 minutes, and demonstrate that no matter what you select, as long as it's artifact free, that the patient has the same linkage. In this case, this individual was assaulted and struck in the right parietal region. He's paralyzed on the left. He has spatial neglect to his left side of the visual field. He doesn't shave the left side of his face. So there's the classical symptoms of right parietal lobe damage, and you can verify that deviation in the parietal lobes at the surface, as well as using the NeuroNavigator. So I'm now just going to go immediately to the NeuroNavigator, and then we'll go back, as I mentioned, to the NeuroLink Pro. I've already launched the NeuroNavigator. To get there, you click Analysis, NeuroNavigator, and generate it. But I've got it up here going already. This is the scalp EEG. It happens to be at 5 Hertz. And I've selected the attention network. And the Brodmann areas representing the attention network are shown here. I can sort them by severity of the This is raw values. I'm going to go to z-scores. The severity of, or the magnitude of the z-scores is 3.948, and the right parietal lobe, right broadband area is 7, broadband area 40 is 3.8, standard deviation is broadband area 39. Again, the parietal lobes, and then there's a right frontal here, another right frontal. And there was a coup, contra coup, and so there's a slight deviation on the left, but it's more in the frontal lobes. And so we can see the deviation from normal and the electrical potential. I'm going to get rid of the scalp map and just take a look at the network. I'm going to make sure that I got connectivity. So you can see all of the hubs. I'm going to get rid of the cortex. In this case, that's information flow, but let's look at coherence. I'm going to again set the Z to, it goes by default to 1.65 to 3, but I want to be able to show all of the hubs and connections. The Z-scores in the lower left here, the green is within the normal range, and the yellow, etc. As you move your mouse, you can see the magnitude of the Z-score deviations that are there. And so this is how we assess this network. We identify the hubs that are deviant from normal. Here, for example, is this connection is hypercoherent. I can evaluate where that hub is. That's broadband area 7 right. The hyperconnectivity is to broadband area 39 right. And then there's broadband 40 right. And the right frontal lobe, broadband area 6. So you can identify these hubs and connections that are deviant from normal if you wish. You can also look at other types of symptoms. For example, we can evaluate Parkinsonism. In this case, I'm going to look at the volume view so you can get a better view of the hubs of the cerebellum, where the cerebellum hubs are deep inside here, as well as the subthalamus, the thalamus, red nucleus, and then the somatosensory cortex. And you can see the connectivity and the deviation from normal of the current sources themselves. And this network for a patient whose symptoms are Parkinsonism. One can then target this network, reinforce greater stability and efficiency. The cerebellar connections to the sensory motor cortex do not involve dopamine, so as dopamine degenerates in the striatum, in the thalamocortical dopaminergic circuits, then the symptoms are very severe, but there's compensatory dynamics that's possible, like with sensory motor SMR neurofeedback that's been demonstrated in monkeys and humans, which is a parallel compensatory circuit that improves gait and helps reduce the severity of the Parkinsonism. So this is where we're going to end up, but for now, I'm going to return to NeuroLink Pro, because this is where we're going to be working, but I also want to be able to show, now let's just go ahead and start here and I'll show you how to get there. I'm going to log in, and this is NeuroLink Pro. We can select a subject. We've already got some reports, and so I'm going to look at, I'm going to look at the questionnaires that we have. General survey, autism, depression, pain, suicide for the Department of Defense. There's a lot of people there's an increase in suicides and depression because of the problems with coronavirus and other stresses that soldiers have. We also have a coronavirus questionnaire that is dealing with the severity of the symptoms of coronavirus, just because this is a special moment. And in any case, these are all separate questionnaires that self-report the severity of the symptoms. I'm not going to go into this particular one at this time because I'm going to do that on the smartphone. I'm going to cancel. This comes up because this whole process is HIPAA compliant. So if you cancel, you have to actually go back to the opening screen for HIPAA purposes. Now I'm going to come back to this in a moment, and for now, I'm going to take a look at the smartphone app. I'm going to go to the home screen, which I have to actually click with my finger. This is what you'll see, linking symptoms to brain networks. This app is in Android and the iPhone. You then can click continue, it will automatically go there. You can click on test, and then we have the general survey, for example. These are statements about the general survey. I'm going to continue. I'm going to now take the test just by clicking on it quickly. Have cravings for alcohol or drugs. I'm easily distracted. People usually have to repeat words to me. I have blurred vision. I have chronic pain. And I'm just going to go through these quickly, just randomly clicking so I get through it. Obviously, when a patient does this, they need to pay attention and be honest about their self-assessment, because otherwise they're wasting everybody's time and their own money. And by the way, this app is free, and you can take it as many times as you want. But when you actually when an individual does contact a clinician through the map I mentioned, and I'll show in a minute, one can then arrange for treatment and expand the number of tests and assessments of the patient. So this is the assessment. For example, here's the memory network, and you can move it around. You can get rid of the cortex, put it back in. You can expand it, contract it with your fingers. You can look at the depression network. Now the colors depend upon the severity of the symptoms. If it's green, then that means the severity is low. Yellow is moderate. Red or orange is severe. So you can play around with these. Here's the pain network. You can then look at the history, and there's been multiple tests, and you can look at the severity of the symptoms as a distance from the center. So the goal is to move the networks, hubs, and connections towards greater stability and efficiency, and the symptom severity should go down, whatever the treatment is. And in this case, I'll be using a lot of with neurofeedback. But one can then send this information to the clinician by clicking the little box there, and I'm just sent it to myself. Now that happens, I'm going to delete, by virtue of coming to the map. I'll go back there so you can see it. This is the map that you saw in NeuroLink Pro. And now I'm going to select the clinician. In this case, I'm going to select myself. And there's where I'm located with my contact information, etc. So this is a map. And the contact information can include your email, your website, what your degrees are in, what your specialty is, etc. Clinicians will subscribe so that people can get in contact with the clinician. Also, this is anonymous and HIPAA compliant. Patients can, it's particularly important for the stigma of suicide and depression, get connected to a clinician without giving away their identity. So it's anonymous, and the clinician and the patient can arrange for whatever way they want to eventually get connected without stigma. That way, this is particularly important for the military, because that's a special problem with soldiers having to report in a hierarchical command. We can look at previous results. I can go back to the graph. I'll look at attention problems. That's the network. This is the information about the attention network, and all these networks have that information. I go to history, etc., and take other tests, or have the patient take other tests to get an assessment of the severity, and also to be able to go to let's go back, to send this information to the clinician. So like as I mentioned, you can do it in this manner, and there's other ways as well. Now the clinician, and I'm going to switch back to NeuroLink Pro, will receive this information and NeuroLink Pro on a desktop or a laptop or any number of platforms, and then you can see here that the same map is there, and the clinician now can import the test that was or the assessment that was done and saved on the smartphone. One can also launch NeuroGuide. One can evaluate the test results, similar to what we did before, and look at different networks. This is the same as it's in the app, smartphone app, but this is NeuroLink Pro. One can put in new patient information, get information about the individuals and their clients. This is the information about the client. You can search. You can, in this case, get access to the NeuroLink app. And then you can export this file, the file that is the test, to be put into NeuroGuide. This is .nla file. So for example, if we have the patient in the office, they were in the waiting room when they filled out the questionnaire, or they're at home or wherever, then the patient's EEG is streaming, and one can then immediately do neurofeedback and use SW Loretta neurofeedback. We know that his attention problem is it's a big issue. That's NeuroLink Pro. I'll be getting to that in a minute. So I'm going to go up to where our data file is, where actually I have the demo information, and I already have done a symptom checklist match, which is a normal procedure to do. And now I'm going, and I saved it in the patient's folder, and all these files should be saved in the patient's folder. And now I can go and pick up the NeuroLink and browse and get the NeuroLink information that I saved from the smartphone or from the NeuroLink Pro. For example, here's the depression network. We can select any of these. The hypotheses are network hubs produced by the over 30,000 peer-reviewed journal articles in the National Library of Medicine database, that is PubMed. Most of these are PET scan. They're much more accurate than functional MRI and replicable. And at the National Institutes of Health, we were able to, this is actually we cross-validated EEG and magnetic electroencephalography or encephalography with PET scans and SPECT scans. Later in the 1990s, the functional MRI became more perfected, and a lot of the times you can also co-register functional MRI. There's a lot more noise bouncing around compared to a PET scan. But nonetheless, these are well established and linked to symptoms based upon the neurological history of strokes and tumors and penetrating head wounds, as well as a variety of neurological or psychological issues that are present in patients that have been evaluated using PET scans. The interconnectivity network, which is up here, is an example of a paper by Laird, which is over 30,000 assessments. I think it's about 8,000 subjects. And there was high consistency in these hubs, primarily in the PET scans, but also with a selected group of functional MRI. So now we can begin our neurofeedback. And these are the Brabant areas that match up with the PET scan, functional MRI, scientific literature, and neurological literature, and neuropsych literature. These are the ones that mismatch and they'll be excluded. And I'm going to click OK. I'm going to click, in this case, I'm just used the green head, which is a green dot that will, I'm going to go to Z-Tunes, will be activated when the patient is, you can see the instantaneous deviations from the threshold and here's the feedback signal. And so what we've done is started with the patient's symptoms, assess the patient's symptoms using NeuroGuide and particularly the NeuroNavigator. Then we imported the severity of the patient's symptoms and the networks that are most deviant from normal into NeuroGuide. And then we begin our neurofeedback, targeting the hubs and connections which are linked to the symptoms and are most deviant from normal. The goal to reinforce greater stability and efficiency in the patient networks that are related to the patient's symptoms. So that's how NeuroLink works. It facilitates linking patient symptoms to the patient's brains and to be able to evaluate the relative efficacy of treatment. So you can look at treatment over time, over sessions. So it gives the clinician feedback, quantitative information, important information about symptom severity, in parallel with improvement in the efficiency and stability of network hubs, brain hubs and brain connections, as one then helps patients towards greater and improved mental health. So that was a brief introduction to NeuroLink. We will be releasing NeuroLink next week. And a lot of time and energy went into this program, and I hope that people enjoy it. We'll have complete documentation and webinars and help by our great customer support team at Applied Neuroscience. So thank you for watching.